Hey everybody. In class we've been working on solving one and two step inequalities. Today we're going to take it up to the next level and we're going to look at some multi-step inequalities. We're just going to do 4 examples. Some of these are going to be pretty complicated, so make sure you're following along closely. In our first example here, we have an inequality. I'm not even going to read this out loud because there's so much stuff going on. First thing I'm going to do is separate the two sides through the inequality. Okay, this really lets me narrow it down to what I got to do on each side. Now, before we start solving, we want to simplify both sides. Write each side as simply as possible. On my left side here, I'm going to have to distribute. I have 4 times 3x, that's going to give me 12x. And I have 4 times negative 1, that's going to give me negative 4. Now I haven't done anything to both sides yet, so nothing's going to happen with our inequality. And on the right side, we are going to have to combine some like terms, because I see we have a 10x and we have a positive 5x. So 10x plus 5x, that's 15x minus 4. Now here, there's a few different things we could do. Okay? I'm going to subtract 12x from both sides because I like to deal with positives when I can. So subtract 12x from both sides. 12x minus 12x, that's going to be 0. I'm left with negative 4. Don't forget that negative sign. A lot of people do. Is less than 15x minus 12x is 3x minus 4. Now that I have x over on the right side, I'm going to get rid of this minus 4, add 4 to both sides. Ooh, that's nice. I'm going to get a cancel there. We have 3x. Our inequality is still the same, and we have 0 over here. Negative 4 plus 4 is 0. Now to solve for x, I can finish the problem by dividing by 3, and I get x. Our inequality is still the same. We divided by a positive number, and 0 divided by 3 is still 0. So my inequality here says 0 is less than x. But we always want to make sure that we're looking at it from the x's point of view. We want to think about what are the possible values of x. And if we're reading it from the x's point of view, this says that x is greater than 0. We can even rewrite it. We can write x is greater than 0. If we switch the x and the 0, we've got to make sure we flip that inequality too so that it's facing the same way relative to the x. And now that we have our inequality written, we have it solved for, we can graph our solutions on a number line. Now 0, since that's what we're starting from, I'm going to put that in the middle here. Let's label 1 and 2 over here. We can put negative 1 and negative 2. And I'm going to plot x is greater than 0. So I have an open circle at 0. It's not closed because it can't be equal to 0. And I want the numbers that are greater than 0. So we go to the right. We shade in 2, 1, and all of the numbers in this direction. Alright, here we have a really friendly looking inequality. Lots of steps to do in this one. Let's try to make it as simple as possible by splitting the two sides. Now on my left side, I have 2 things I'm going to have to distribute here. I'm going to have to distribute this 3 times x and 3 times 4, 3x plus 12. And then here, I'm going to need to distribute this. Now, I can treat this as a negative 1. Negative 1 times 7 is negative 7x. Negative 1 times 4 is negative 4. Now, I'm going to keep simplifying what I have over here on the left. I can combine like terms now. 3x and negative 7x are going to give me negative 4x. And 12 plus negative 4 is going to give me positive 8. Negative 4x plus 8. So my left side is fully simplified. On my right side, I can combine like terms. I have x and negative 5x. This is like 1x, right? 1 plus negative 5 is going to give me negative 4x. And then negative 12 plus 3 gives me negative 9. Now I haven't done anything to both sides yet, so my inequality hasn't changed. Now I want to eliminate one of my variables. Let's add 4x right here, and we got to make sure we do that to both sides. Now negative 4x plus 4x, that's 0, so those cancel. We have 8. Cancels over here, we have negative 9, and our inequality is still the same. Now, we have no variables here. There's nothing else to do. All we're left with is 8 is greater than negative 9. The thing is, it doesn't matter what x is, this statement is always true. So we can say that this inequality has infinitely many solutions. We can also say that all real numbers are solutions. All real numbers. Now, if we wanted to show that on the number line, what does it look like when all real numbers are a solution? We have a number line. We have 0. I'm going to put negative 1 here. I'm going to put positive 1 here. If all real numbers are solutions, that means every single number on the number line is shaded in, going forever in both directions. Okay? All real numbers make this inequality true. Alright, this is actually going to be our third and final example. I'm going to start, as I did all my other ones, draw a line through my inequality so I can keep my two sides nice and separate. On my left side here, if I want to simplify, I can combine like terms. I have 11x and I have negative 1x. 11 and negative 1 gives me 10x. And then we have minus 3 left over. On the right side, I want to distribute this 3. That's going to give me 18x. 3 times negative 5 is negative 15. And then I have minus 8x. Okay? And I'm going to need to combine like terms here. 18x and negative 8x gives me 10x minus 15. Now over here I have 10x minus 3. And nothing has happened to our inequality yet. Nothing's changing. Now I can subtract 10x from here to eliminate this x and do the same from here. I'm subtracting 10x from both sides. I'm going to get canceling here. I have negative 3. Those cancel as well. We get negative 15 over there. Negative 3 is less than or equal to negative 15. Now, in this case, negative 3 is less than or equal to negative 15. This is never true. Negative 3 is never less than negative 15. Negative 15 is more negative. This statement is never true. And since it's never true, instead of all real numbers being solutions to this inequality actually has no real solutions. There's not a single real number that we can substitute for x that will make this inequality true. Now what this looks like on the number line, if there are no solutions, right? We have a number line. It doesn't even matter what numbers we have on here, right? We have nothing shaded in. There's not a single number on this number line that makes this equation true. So if we were going to graph this solution, it would be an empty graph. Alright, I'm going to throw a bonus problem on at the end of this one. If you're not interested, you don't want to do it, you don't have to, you're fine with the 3 examples we already did. But if you want to follow along, you want to see a little more complicated problem, feel free. I'm going to start this one again by drawing my line through the inequality. Now, I have 2 fractions that I'm adding together on the left side of this inequality. One way to solve this equation would be to find the common denominator of these 2 fractions. Now 5 and 2 are my denominators, and I know that 5 and 2 both go into 10. So what I could do is multiply this denominator by 2, which means I would also have to multiply this numerator by 2. Same thing with the second denominator. To get 10 I would have to multiply by 5, which means I would have to multiply this entire numerator by 5. Now that will give me 10 in the denominator for both of these fractions, And in the numerator for this first one, I'm going to have 2x minus 6. For my second fraction, I'll have 15x minus 10. And this will still be greater than 11. Nothing's changed yet. Now, since my denominators are the same, I can add these two expressions together. So really, this becomes 17x minus 16. I'm really just combining like terms here since this is an addition problem. And this is over 10 is greater than 11. Now, to continue solving this, I'm going to need to get rid of this denominator. Since this says divided by 10, I'm going to multiply both sides by 10. Now, these 10s cancel out because we used our inverse operation. So we now have 17x minus 16 is greater than 110. The inequality didn't change because we just multiplied by a positive number. Now, this is just a two-step equation. I'm going to add 16 to both sides, plus 16. We get 17x is greater than 126. We divide by 17. X is greater than... Now, 17 doesn't go in evenly to 126. And because 17 is a prime number, I can't really simplify this fraction. The best way to leave this answer is just as an improper fraction, 126 over 17. And that's our solution.